In this video, I'm going to go over integration by trig substitution using the tangent method. So we're using the identity already here, just for reference, tan squared of an angle, I'll call it theta. Okay, tan squared theta plus 1, that's equal to secant squared of our angle theta. Okay, so why do we need to use this? Well, first of all, let's talk about when we need to use it. We need to use it when we're square rooting a perfect square with a variable plus a perfect square constant. So the order of the constant and the variable can change because the order that we add something doesn't change. So this could be the square root of 9 plus 16x squared, right? We can always switch those around because of the plus there. It doesn't matter. The important thing is we have a variable being squared, and that's adding into a constant being squared. Okay, so anytime we have something like 16x squared plus 9 being square rooted, we're going to look at the inside of it only. So we're not going to worry about that square root right now. Okay, so what we're going to do is we're going to remember that if we have, it's similar to like I did in the other video. If we have the square root of, let's call this 16x squared, let's say that's an entity u squared, right, plus a squared, where a is just a constant, we're going to say that u is equal to a tan theta. Okay, so for all these trig substitution videos, it's going to be different depending on which method you're using. In this case, it's tangent. So the thing you're squaring, in this case, it's u, but 16x squared is u squared. So u in this case is 4x. So if this is the case, then 4x, all right, therefore 4x, right, because 4x squared is 16x squared, which is right here. So u squared plus a squared, well, that means a must be the square root of 9, which is 3. Then we're going to put 3 out in front here, tan theta. And how can we do this? Well, I'm just going to, let's take a look at this part right here. So I'm just going to draw an arrow, right? If we said that u is equal to a tan theta, instead of u in this radical, let's put a tan theta. So this would be the square root of a tan theta squared plus, right, plus a squared. So it should be the same thing so far. A tan theta squared is just, we have the square root here, a squared tan squared theta plus a squared. Notice how we can factor out an a squared. So we get the square root of a squared times tan squared theta plus 1. Remember, tan squared theta plus 1 is just secant squared. I wrote that up here for reference. So this is just the square root of a squared secant squared. Oops. Right, and we can square root a squared and secant squared, so we just get a times the absolute value of secant theta. So let's not take shortcuts, right? Let's actually do the math. Instead of writing a and tan theta, let's use x. Okay, so we can predict that it's going to be a times secant theta. We know a is going to be 3, so it's probably going to be 3 secant theta, but let's just write it out. Okay, so we know that our integral, right, we can rewrite it as u squared plus a squared. Okay, so what we're going to do now is we're going to replace that with, well, we know 4x is going to be equal to 3 tan theta. Right, so what we're going to do now is we're going to replace the 4x with 3 tan theta. Make it a bit longer. So this will be, instead of 16x squared, we're going to write 3 tan theta squared, right, plus we have our 9, right, that's just a squared, so it stays as 9. All we're doing right now is replacing 16x squared with 3 tan theta squared. Okay, that's going to be equal to, well, if we square that, that's going to be 9 tan squared theta plus 9. So remember, we're seeing these 9s show up just like we did with the a squareds. Now, same thing, we're going to factor out the 9 like we did with the a squared. It's going to be 9 tan squared theta plus 1. Remember, tan squared theta plus 1 is just secant squared, so I'll replace that with secant squared Okay, square root of 9 is 3. Square root of secant squared is just absolute value of secant. Okay, and the reason we're saying the absolute value is because when we square root it, we can get a plus or minus, but in this case, we only want plus. And actually, like I mentioned in the last video with sign substitution, when we square root it and get a trig function left, we don't need to keep the absolute value bars because when we do indefinite integrals, it actually doesn't matter because we just assume that everything's positive. So even though it's 3 times the absolute value, we're just going to say 3 secant theta when we plug it into our integral here. Okay, so let's, I'm just going to copy this integral and kind of bring it down. Okay, copy that. Paste, okay. So I'll put it right here. So this is our integral, and instead of writing everything in terms of x, remember, let's write everything in terms of theta. So the square root of 16x squared plus 9, right, we figured that out to be 3 secant theta, right? So that's a lot cleaner than what we had before. So 3 secant theta on top. And on the bottom here, we have x to the 4th. That's kind of weird, right? Well, if we want x to the 4th, first we have to figure out what x is in terms of theta. And remember this up here, I'm just going to copy this as well. Okay, so if we know that 4x is equal to 3 tan theta, well, if we just want x, we just divide both sides by 4, and we get x is equal to 3 over 4 tan theta. Okay, so if we want x to the 4th, we just take the quantity x, which is really 3 over 4 tan theta, to the power of 4. Okay. So now, one thing that's missing here, I'm just going to grab my calculator. Okay. I don't have it with me, so I'll just use my phone one, but one thing that's missing here is the dx, right? We substituted this radical, right? And then we got x to the 4th going here. We substituted all that in, but we're leaving out this dx. Okay, so in order to find dx, right, we have to figure out what dx by d theta would be. So I'm going to write dx by d theta. Right, so if x is 3 over 4 tan theta, right, we just figured that out, well then the derivative of 3 over 4 tan theta with respect to theta is going to be 3 over 4 secant squared theta. And then if we just want dx, we multiply both sides by d theta. So we're just going to get dx equals 3/4 secant squared theta d theta. Okay, so that's what I'm going to write here. Instead of dx, I'm going to write 3/4. So times 3/4 secant squared d theta. Okay, so I'll get this out of the way. So now, basically all we did was we transformed this initial integral into this integral here in terms of theta and a bunch of trig functions. So there's lots of different identities that we can use for integrals like this, but a lot of the time when we have like tan and secant and cosecant, a useful method is just to get everything in terms of sine and cosine. Okay, so if we have 3/4 tan theta raised to the 4th power, the first thing I would recommend doing is probably multiplying this 4 into the 3/4 and the tan theta. So kind of just expanding that power out. And also we have secant times secant squared. So this will be on the top, let's see, this will be 9 over 4. Right, 9 over 4 secant cubed. And then we have our d theta over here. So 3/4 to the power of 4, that's 3 to the 4th, which is 3 times 3, right, which is 9 times 3, 27, times 3 is 81, over 4 to the 4th, so that's 4 times 4, which is 16, times 4, which is 64, right, and then if we multiply 64 by 4, we get 256, so 81 over 256, okay, and then we get tan to the 4th, theta, and then I forgot my theta here. Okay, we're just kind of trying to simplify things as much as we can here. So let's see what we can do. We can, so 9 over 4 divided by 81 over 256. This is the same as 9 over 4, right, times 256 over 81. So we can factor those constants out, and then we have the integral left of secant cubed theta over 10 to the 4th theta d theta. Okay, now let's just kind of work out this fraction here. So it's going to be 9 times 256. I'm going to try and do this in my head here. 9 times 256. That's going to be 2,304. Okay, and then we got 4 times 81, so that's going to be 324. Okay, if we divide both sides by 2, it's going to be 1,152 over, so it'll be, I'll just write it over here, 1152 over 324 over 2 will be 162. We can divide that by 2, so 162 over 2 will be 81. So 81 over 1152 will be 576. Can we divide 576 by 3? Yeah, it'll be 192 over 27. Can we divide 192 by 3? Yeah, that'll be 64 over 9. Okay, so there's probably an easier way to simplify that, but we ended up with 65 or 64 over 9. And we can we divide 64 by 3? No, we can't. That'll be like 21.3. Okay, so we're left with 64 over 9 on the outside. Sorry, that took a little longer. I don't have my calculator, but it'll be 64 over 9, right, times the integral. Secant cubed, let's just simplify this over here. Secant cubed theta over 10 to the 4th. Right, this is going back to our trig identities, how to simplify stuff like this. Well, this is, secant is 1 over cosine cubed, right, if we cube secant. And then times, if we're dividing by tangent, that's really like multiplying by cotangent. Cotangent is cosine over sine, so that'll be cos to the 4th theta over sine to the 4th theta. So 3 cosines will cancel, so we'll get cosine over sine to the 4th. Cosine over sine to the 4th. Okay. Cosine over sine to the 4th theta d theta. Okay, we're getting there. Now, this is an instance where we can use integration by u substitution, because notice that the derivative of sine is cosine, and we're only multiplying or dividing. There's no like weird addition going on. So if we say let u equal, we'll go sine theta. If we did cosine, we get a negative. Du will be equal to, well, the derivative of sine is cosine, so it'll be cosine theta d theta. Okay, so that kind of covers it. If u is sine theta, well, this will be equal to the integral of 64 over 9 times the integral of, well, the cos theta d theta, right? That's these two terms right here. That's covered by just saying du. So I'll write du over here, and then we'll get 1 over sine to the 4th. Sine is just u, so that's 1 over u to the 4th. 1 over u to the 4th is just negative, or u to the negative 4. So we've simplified this integral a lot here. Now if we integrate this, it's going to be, well, let's see here, it'll be negative 64 over 9 times, oh no, hold on. Let me just think here. If we use our power rule, right, we are increasing the exponent of negative 4 by 1, so u to the negative 3, and then we're dividing by that new exponent there, so dividing by negative 3. So that'll be 64 over 27, but negative, so this will be negative 64, and then we're dividing by 3, so 27. and then u to the negative 3, so times 1 over u cubed, and then we have our plus c. Okay, so we have a couple steps left, right? Because we have it in terms of u, we have to get it back in terms of theta, and then after that in terms of x. So it's a bit of a process here, right? U, remember, we said u was sine theta, so it'll be negative 64 over 27 sine cubed theta, right? Because the u and the 27 are kind of going to join each other. U was sine, so u cubed is sine cubed, right? And then we have our plus c. Okay, so we are getting there. We have it in terms of theta, which is kind of the first step we did, was we got in terms of theta. Also, one thing I would do after this is, instead of writing over sine cubed, I would just write negative 64 over 27. Sine is 1 over sine is really cosecant, so it'll be cosecant cubed theta plus c. Okay, so if we want to figure out what theta is, right, we're going to have to use our knowledge of trigonometry. Okay, so if we said up here, where did I say it? I said that 4x was equal to 3 tan theta, so let's actually bring that down here. Can't bring it down, so 4x is equal to 3 tan theta, right? But let's think about what just tan theta is. So let's get the tan of our angle, right? If we have our triangle right here, I'll draw it out. The length of the triangle doesn't matter because we don't know what x is, right? So there's no point in trying to like scale it for a number we don't know. Tan theta is going to be equal to 4x over 3, so I'll write 4/3 x. So if this is theta here, right, the tan of that will be 4/3 x is the same as 4x over 3. So I'll write 4x over 3, right? Tan theta is opposite over adjacent in SOHCAHTOA. So the opposite side to the angle is 4x, and the adjacent side is 3. Well, remember, this is a right triangle we kind of hypothetically made up, so we can use the Pythagorean theorem to find the missing side. So 3 squared plus 4x squared equals, I'll call it L squared, right? So 3 squared is 9 plus 16x squared equals L squared. So that means L must equal the square root of 16x squared plus 9. And notice that was the original radical that we started with, right? The square root of 16x squared plus 9. That's not a coincidence, so that's going to come up every time you're doing these questions, okay? So anytime you're doing a trig substitution, the length of your triangle that you have to draw in the end to get theta in terms of x, it's always going to be the original integral, or the original radical, sorry. So this will be the square root of 16x squared plus 9. If you don't get that, if you don't get your original radical, then you probably did something wrong along the way. So that's kind of an indicator to just kind of look back on your work. Okay, so what's the point of even doing this? Well, we figured out what the integral was, except the question, right? The question gave our variable in terms of x. If you write this on your test and leave it in terms of theta, you're going to get no marks other than some maybe partial marks for the work to get there, because this isn't the actual answer, right? Because you started with a variable x, you have it in terms of theta, we have to convert it back now so it's a credible answer. Because theta is just some arbitrary thing that we made up as a variable, right? To represent like our triangle and our ratios. So remember cosecant, right? That's 1 over sine. Sine is opposite over hypotenuse, so 1 over that must be hypotenuse over opposite. So I'll write here cosecant cubed theta equals, it's going to be hypotenuse over opposite cubed. Okay, so our hypotenuse, let's think here, our hypotenuse is going to be, actually I'll write it without the brackets now. This will be the square root of 16x squared plus 9. And I'll make this a bit smaller. And this is being cubed, so actually I will write brackets around this one. And then over O, so remember O is opposite to our angle theta. So that's going to be 4x, all of that cubed. Well, 4 cubed is going to be 64, so that's 64. That's going to be 64x cubed. Okay, so now that we know cosecant theta is this quantity here, we can plug that in. So negative 64 over 27, so I'll write I for integral, negative 64 over 27, and then we had cosecant cubed plus c. Well, now we know what cosecant cubed is, right? And I'll write this, instead of a square root being cubed, I'll just write it as the stuff inside the square root to the power of 3 over 2. Okay, so negative 64 over 27. This is, actually I'll write it a bit bigger. So 64 times 16x squared plus 9 to the power of 3 over 2 divided by 64 times 27. And then we got, I'll just write x cubed, right? That's our bottom. And then we have our plus c. So notice how the 64's cancel, right? And what we're going to be left with is, this will actually work out nice. We're going to get negative, negative 16x squared plus 9 to the power of 3 over 2 over x squared. Or sorry, x cubed, 27x cubed. Oh, can't mess up now, all that work. 27x cubed. So this is your answer for the integral. So the bad news is this takes an excruciating amount of focus and energy and work. But the good news is there's not like a ton of ways you can kind of reframe these questions. So if you want to use tangent trig substitution, you have to recognize that there's the square root of a variable squared, or a perfect square with a variable in it, plus a perfect square constant, and then it can be being multiplied by maybe like x to the power of something, or divided by x to the power of something. So basically just this radical here, and then a rational expression kind of multiplying or dividing into it there. And typically it's in terms of x, you want to get it in terms of theta. Maybe they gave it to you in terms of theta. When you're doing your substitution, you want to get that in terms of x or some variable. Remember, people think like they put too much emphasis on like what tan theta even means, or what theta even means. Theta is just like a variable that we're kind of filling in for x. So what we're doing is we're substituting, that's what this video is called, right? Trig substitution. Like none of this stuff actually means anything. It just represents like what the triangle is going to look like after we kind of do our u substitution and get it in terms of like sine and cosecant, right, with theta. So once we have this theta, we can use our knowledge of triangles to get it back in terms of x, but theta itself doesn't hold any deeper meaning. So x is what we're really looking for, right? Our integrals in terms of x, and this dx kind of indicates that. So I hope this was helpful. I'm going to do a last video on trig substitution using a rational power and secant substitution. So there's typically like 3 kind of methods that you can use. After those 3, you should be good. And yeah, I'll see you there.